Hello everyone. Good evening to all of you.
Good evening, sir.
I hope I'm audible as well as visible to everyone. I'm just sharing the board.
Yes, sir.
So today we are going to start very important lesson topic of geomorphology, and that is origin of ocean and continents. And from this particular topic, you are going to have question in your mains examination. We are intended to learn about precisely continental drift theory and plate tectonics. Okay, and we will also try to understand the historical background, how this theory evolved, and from where the starting point can be, which is important for your examination. So I have shared the board. Is it visible?
एक्सक्यूज मी सर।
हाँ बच्चे बताइए।
सर इरोजन बाद में करेंगे।
हाँ, इरोजन इरोजन साइकिल इसको पहले कर लेते हैं, कॉन्टिनेंटल ड्रिफ्ट फिर उसके बाद कर लेंगे। इरोजन का बेसिक अंडरस्टैंडिंग आपको पता चल गया।
यस सर।
विदरिंग और इरोजन दोनों करा दिया था कि इरोजन बचा था?
इरोजन एब्रास से ट्रेसन किया था।
इरोजन साइकिल बची थी कि पूरा इरोजन बचा था बच्चे?
पूरा इरोजन बचा था।
अच्छा, तो फिर बेसिक्स ऑफ इरोजन कर लेते हैं। कल से हम लोग कॉन्टिनेंटल ड्रिफ्ट, मुझे लगा इरोजन करा दिया है। ओके, सो लेट्स बिगिन विथ इरोजन। टुडेज क्लास इज बेस्ड ऑन इरोजन। सो लेट मी चेक व्हाट वाज द लास्ट टॉपिक आई हैव कवर्ड। क्या था, कुछ बताएंगे आप?
सर बेसिक्स शायद हो गया था।
टाइप्स ऑफ इरोजन करा दिया था, केमिकल इरोजन, फिजिकल इरोजन।
नहीं नहीं नहीं।
मुझे पिछली क्लास का डिटेल मिले तब तो कहाँ पे रख दिया मैंने। रॉक्स एंड मिनरल सिस्मिक वेव। Mountain building forces, weathering and erosion. I think biological weathering. We discussed about weathering, na?
यस सर।
Weathering we discussed. Erosion is left over, na? Okay, fine. So let me start with erosion. Then I will discuss the next topic. So today we are intended to learn about erosion. इरोजन साइकिल को हम लोग बाद में करेंगे, जब हम लोग पढ़ लेंगे कॉन्टिनेंटल ड्रिफ्ट वगैरह, आइसोस्टेसी। तो उसके बाद इरोजन साइकिल, डेविस पेन, केल्सी किंग, स्लोप डेवलपमेंट, ये सारी चीजें आपको वहां बताई जाएंगी। फिलहाल बेसिक्स ऑफ इरोजन। सो व्हाट इज इरोजन? इट्स अ डायनामिक disintegration dynamic disintegration of the rock. Dynamic disintegration of the rock, and there must be some active agent, and this active agent will be also called as erosional agent. And here it can be water, it can be glacier, it can be wave, wind, sometime underground water, underground water or groundwater. So all these agents can be active, and they perform the process of erosion. They perform the process of erosion. Wait for 1 minute. I just close the door. Yes, let's talk about erosion. So, erosion require an agent, and this agent can be water, glacier, wave, wind, or it may be underground water. It creates dynamism, and due to dynamism, there is disintegration of the rock, which we call erosion. For example, suppose that this is the bedrock, fine, and one rock is moving on this bedrock. This is a rock which is in action because of certain agent. It can be water. Mostly it is water or glacier. Okay. It can be anything, but do remember when a rock is moving, certainly there will be frictional force generated between the bedrock and moving rock. So this is what the interface where you will find force, frictional force that develops between bedrock and this moving rock. And due to this friction, there will be disintegration without any doubt, and this rock as well as bedrock will be disintegrated into small fragments. These are small fragments which we call sediments. Another name, alluvium, or we call it colluvium, or we call it moraine. These are the different name. Moraine, this is also called as loess. Fine. So these are the name of the fragments. When we call it alluvium, when the agent is running water or any river. So if river is there, active agent of erosion, then it is alluvium. Colluvium, when there is a glacier, obviously moraine is the name of colluvium, glacier. Loess is the sediment brought by wind. So on the very basis of different erosional agent, we have different sediment. Fine. How this sediment was created? Because of the frictional force generated due to dynamism of the rock with the bedrock. And the process is called as corrosion. 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 Or it is also referred as abrasion. 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 So what happened in corrosion and abrasion? The moving rock is in continuous friction with the bedrock, and there is disintegration. And the agent of erosion may be either water, glacier, wind, and on the very basis, the fragment have different names. Fine. And this process takes place, which is called as corrosion. So you can take down when a rock is moved, when a rock is moved on bedrock, bedrock, with the help of, with the help of any dynamic, any dynamic erosional agent, it is it is in continuous, it is in continuous, in a state of friction, friction with the bedrock, with the bedrock. Consequently, or as a result, both the rock, both the rocks get disintegrated. both the rock get disintegrated into finer fragments. Finer fragments or sediment or whatever the name you like, finer fragments. The process is process is called as abrasion, abrasion or corrosion, abrasion or corrosion. So this is what corrosion when a rock is moving by any agent, fine. And there is a continuous friction with the bedrock, and this friction is responsible for disintegration. So you understand abrasion. So first kind of corrosion, this erosion is corrosion or abrasion. Do remember it's corrosion, not corrosion. Na? This is corrosion. Let's talk about attrition. The second type of erosion is attrition. अब attrition में क्या होता है बच्चे? Again, there is a rock which is moving. So this moving rock, suppose that this is rolling rock, collided with another rock. So there will be another rock which get collided, and it is moving because of certain agent, right? Certain agent, and the agent must be here water, because water can move the rocks, as well as gravity is also there. Gravity is responsible for movement. Gravity plus water both are going to cause this kind of movement. And due to this movement, these are colliding with each other. So there is a collision between two rocks. So there is a rock, let's say for pictographical representation, R1 and R2. These are the two rocks moving and they collided with each other. Collision. And due to collision, it is but obvious they get disintegrated, they get fragmented, they get broken down. Okay. This fragmentation means because of collision, there is a fragmentation, and that is called as attrition. So you can write attrition is a process in which both the rocks, both the rocks collided with each other, and get disintegrated fragmented. And the process is called as attrition. Here the agent can be water along with glacier, or water alone or glacier alone. But indeed, gravity or slope is going to facilitate this attrition, process of attrition. अब नदी आ रही है बच्चे, बड़े बड़े बोल्डर्स लेके आ रही है, वो बोल्डर्स बेडरॉक से भी टकरा रहे हैं तो एब्रेजन कर रहे हैं, और आपस में टकरा रहे हैं, कोलिजन कर रहे हैं तो भी टूट फूट हो रही है. And these fragments are what? Alluvium, and they are varying in the size. Sand, silt and clay, pebbles, cobbles, इन सारी चीजों पे हम लोग ऑलरेडी बात कर चुके हैं. ठीक है. Attrition. So water is moving, so it can cause corrosion, attrition. If water is moving, so there is another action which is called as hydraulic action. Hydraulic action. So what is hydraulic? I think I have written right spelling. Hydraulic action. So suppose that water is coming from the mountain. This is the mountain and the river is flowing like this. So this is the flow of river. It is moving like this. But there is a resistant rock. There is a resistant rock in the path of the river. So this rock is resistant enough and it is not being eroded. So what water will do? Water will jump from this rock because it is not going to be eroded. There is no erosion that takes place. So water will do what? It jump from this rock and it is going to create a water. So when water is moving in such a way, it jumps from the rock and hit the bedrock. So here, earlier there was a bedrock. Now, just showing you this level. Earlier there was a bedrock. There was a bedrock. This was the bedrock. But what happened because of the water which is falling from certain height h with mass m under gravity. So obviously it has potential energy that transform into kinetic energy, and this kinetic energy delivered on these bedrock. This is the bedrock. Okay. So water itself, if it is moving and falling onto certain ground, it will deliver a lot of kinetic energy to the ground. And ground contains so many rocks, which is made up of mineral. So obviously, when water has a direct impact, so there is a direct impact of water falling under gravity, deliver massive energy, massive kinetic energy transfer to the bedrock. So moving water has kinetic energy. You understand? There is a kinetic energy. Fine. There is a momentum also. That is what m into v, whatever the velocity. So it has momentum or kinetic energy, and that momentum or kinetic energy will be transferred to the bedrock. And transfer of such huge amount of impact will create shattering of the bedrock. So bedrock get loosely held. Bedrocks get loosely held and removed. Right. Loosely held and removed. There is a depression created. Depression created here. There is a depression created here. And this depression is called as, pothole, and that turned into plunge pool, plunge pool, plunge pool. And the process through which this plunge pool is formed is called as hydraulic action. So water itself is capable enough to create such kind of shattering, such kind of erosion, and that we termed hydraulic action. So waterfall is associated, any waterfall is always associated with plunge pool. So we happen to have plunge pool. Initially, it is a pothole, but later it becomes plunge pool. So there is a hydraulic action. So I think you understand what exactly this hydraulic action, and this hydraulic action can be possible in case of river, and this hydraulic action can also be possible in case of wave. So waves are also doing same because waves are falling onto the ground from certain height. So it also create impact and there is a hydraulic action. So river as well as wave, both are going for hydraulic action and they create different types of landform where the hydraulic action is the prominent process of erosion. I hope I made my point clear to you. What is hydraulic action? Is it understandable to everyone? And when such action is there must be a resistant rock. Resistant rock. अब रेसिस्टेंट रॉक मिल जाती है बच्चे तो पानी क्या करेगा? एक रास्ता है कि वो इसको इरोड करके वी शेप वैली बनाए। अब वी शेप वैली ये बना नहीं पा रहा, इसको सीधे इरोड करके ये जा नहीं पा रहा, तो क्या करेगा? यहाँ से जंप मारेगा, कहेगा क्यों टाइम खराब करे, आगे बढ़ते हैं, धीरे धीरे इसको इरोड करेंगे, है ना? तो शॉर्टकट मार देता है। तो सम टाइम फॉल इज नॉट अगली, इट इज ब्यूटीफुल फॉर गुड रीजन। तो कभी कभी इंसान को नीचे गिर जाना चाहिए, है ना? जरूरी नहीं कि हमेशा आप अच्छे ही बने रहें, और भी बहुत सारे काम हैं जो छूट जाते हैं अच्छे बनने के चक्कर में, है ना? सो दिस इज व्हाट झरना। अच्छा है ना झरना? नहीं बनता तो अभी तक ये रेसिस्टेंट रॉक को नदी काट रही होती, वो अपने डेस्टिनेशन तक पहुंच ही नहीं पाती। इज इट अंडरस्टैंडेबल व्हाट इज हाइड्रोलिक एक्शन?
यस सर।
हाँ, याद रखिएगा जो तरीके आप इरोजन में पढ़ रहे हैं, लैंडफॉर्म डेवलपमेंट में ये कॉन्सेप्ट वहां लगाया जाएगा। So when water is moving, it will cause attrition, it will cause abrasion, it will also go for chemical erosion, isn't it? Physical erosion. So when water is there, all their activity, whether it is weathering and erosion, will be involved to create certain landform. Is it okay to everyone? Fine. So this is hydraulic action. Now let me explain another thing that we call cavitation. Cavitation. So this water which is falling from certain height because of some resistant rock. So the water is moving and it is falling from certain height, and it is also containing rock fragment of varying size. It will be pointed rock fragments, dagger shape. It can be a rounded rock fragment, but ultimately the rock fragment will be here. And as the water falls over here, it creates eddies over here. Means the water is not moving directly, but it creates an eddies and then it moves further. So whenever you will find plunge pool, you just pour water in your glass. Simple water is creating this kind of eddies, and then water moves further. Fine. So this falling water, along with the rock fragments, move in a circular motion in the plunge pool, or you can say circular motion in the pothole. And it is not only water, rather there are rock fragments also. So we happen to have rock fragments. So rock fragments are also moving. Are also moving in a circular motion. And this moving rock fragment acts as grinding tool. Moving rock fragments acts as grinding tool. It grinds the surface. Surface of what? This is the surface of pothole. Grind the surface and further erosion takes place. And this grinding tool is increasing the depth as well as size of pot. Depth as well as size of pothole. And the pothole get converted into plunge pool. Plunge pool. So if you are in any waterfall, you will find that where the water is falling, there is a deep cavity formed, which is called as plunge pool. And when you see the plunge pool, you will find lot of gravels over there, cobbles, pebbles, boulders are there. So the process of this grinding with water is called as cavitation. It is called as cavitation. So you understand what exactly this cavitation is. So with the help of rock fragment, the falling water creates a circular motion in the pothole and it acts as a grinding tool. It acts as a grinding tool and that increase the depth as well as size of the pothole. And the process is called as cavitation. Is it clear to everyone? So I again repeat cavitation. It's a rock fragment along with moving water, creating circular motion. Do remember this is circular motion. Why it creates circular motion? Because falling water create eddies. There is creation of eddies. भंवर बनते हैं बच्चे, है ना? And due to circular motion, the rock fragments are moving in circle and they create a grinding tool that increase the size as well as depth of the cavity which was created, and ultimately it get increased day by day, deeper day by day and bigger, and it become the plunge pool. It become the plunge pool. So you understand what is difference between pothole and plunge pool. आपने pothole देखा होगा, आपके छत से पानी कहीं गिर रहा, वहां पे pothole बन जाते हैं. But plunge pool is a bigger water body, and how it is formed because of cavitation. I repeat again. चलिए आइए देख लेते हैं हाइड्रोलिक एक्शन के लिए मैंने क्या बताया. Water itself, moving water has kinetic energy, and this kinetic energy transferred to the bedrocks, and due to bedrocks, what happened? They get shattered, they get loosely held and removed with time. There is a depression created which is called as pothole, and later on with cavitation it become plunge. So this process is what called as hydraulic action, where this action is possible in case of moving river as well as waves. And why this happened? Because resistant rock is going to block the path of the moving water. So water has to fall from certain height. So there is a waterfall, moving water falling from certain height under gravity will create hydraulic action. Is it okay to everyone? Fine. At Attrition, when both the rocks are moving, colliding with each other at the interface, there is a frictional force, and due to that, they get fragmented, and the process is called as attrition. And what about horizon? When the rock is moving on the bedrock near the interface, you will find this frictional force responsible for disintegration of the rock, and that is called as corrosion. Fine. And this corrosion gives certain sediment, the fine fragment, which can be called as alluvium when the agent is water, moving water, colluvium when it is glacier, or moraine when it is glacier. But when we call loess, the erosional agent must be wind. Is it okay to everyone? Shall I proceed further?
Sir,
Yes, you have some query?
sir, is there any size after which we can say a plunge pool? Like first there will be a pothole, then it will be bigger in size, and then
Yes.
it will be called as a
There
plunge
is
pool.
no such water compartment, watertight compartment like rule when we call it plunge pool. It depends upon how much water is falling. Fine. So pothole in initial case, the depression is called as pothole. But when it is bigger, So when you are considering your drain of your छत, तो आप वहां पे छोटा सा गड्ढा होता है, उसको आप पॉट होल कहते हो बच्चे। और एक बड़ा झरना गिरता है तो ऑब्वियसली कई साल, हजार सालों से वो झरना गिर रहा है, तो एक बहुत बड़ा स्ट्रक्चर बनता है। आप नियाग्रा फॉल का प्लंज पूल उस बड़ा होगा, है ना? सो देर इज नो सच काइंड ऑफ डिमार्केशन कि व्हेन वी कॉल प्लंज पूल, when we call pothole. But yes, initially there is a depression, which is what we call pothole. But whenever we see it in case of waterfall, so waterfall आज के थोड़ी है, waterfall के नीचे हमेशा क्या मिलेगा आपको? You will find this plunge pool, plunge pool, ठीक है? plunge pool बना कैसे? Because of process of cavitation. It is, if bigger waterfall is there, bigger plunge pool will be there, isn't it? So you can say that it's a pothole, which is the initial landform. Initial landform. Any water is falling, so initial landform will be pothole. Okay, and when it is grown up due to cavitation, it will become plunge. Is it fine?
Yes, sir.
Okay. Any query till now? Shall we proceed? Okay. So let me tell you about something wind. If wind is moving, so what it will cause? Wind erosion. So till now we have seen how water is going to erode, but now let's talk about wind. But before that, don't you think if water is there, it will go for solution? Yes or no? Solution, hydration, oxidation, carbonation, carbonation, hydrolysis, hydrolysis. So here the chemical reaction of moving water is also responsible for disintegration of the rock. We have seen it in weathering. And what about frost action? So all these things are associated with water, movement of water, and hence water is going to create lot of denudation through weathering as well as erosion simultaneously. Is it? अब आप थोड़ी ये कह सकते हो कि वाटर, मूविंग वाटर इज गोइंग टू क्रिएट हाइड्रोलिक एक्शन, तो वो जाकर के सोल्यूशन नहीं करेगा। तो ये सारे प्रोसेस हैंड इन हैंड चलते रहते हैं बच्चे। मेरी बात समझ पा रहे हो कि नहीं? जैसे मान लो विंड इरोजन अभी थोड़ी देर बाद शुरू करता हूँ। लेट मी एक्सप्लेन दिस फर्स्ट सो दैट यू मस्ट हैव अ सिंक विद द बिहेवियर ऑफ मूविंग वाटर। सपोज दैट if there is a waterfall, so water is falling over here, so obviously there will be hydraulic action plus cavitation. This will go on. And what about attrition and corrosion? That will also go on. Attrition plus corrosion. But what about solution? अगर पानी यहाँ गिरेगा, यहाँ की जो बेड रॉक्स हैं उनके ज्वाइंट्स और क्रैक्स में जाएगा कि नहीं? बोलो। So when water enters in their joints and cracks, it will go for solution. पूछेगा ना डिसॉल्व हो, soluble हो, तो चलो। अच्छा, solution नहीं करा पाएगा तो हाइड्रेशन करेगा कि नहीं? Yes. और ऐसे हो कि जिनका solution हाइड्रेशन दोनों पॉसिबल नहीं है, तो it will go for oxidation, oxidation, carbonation. बताया था ना बच्चे ये सारा कुछ? बोल नहीं रहे हो तुम लोग?
Yes, sir.
केमिकल वेदरिंग में बताया था ना, तो ये रिएक्शंस होंगे कि नहीं? यहाँ पे होंगे।
Yes.
तो क्यूमुलेटिव इफेक्ट हाइड्रोलिक एक्शन के कारण ये शैटर्ड होंगे, लेकिन लूजली हेल्ड ये इनके कारण भी होंगे। सो द इंटायर प्रोसेस ऑफ वेदरिंग एंड इरोजन ऑफ वाटर इज गोइंग ऑन हैंड इन हैंड। व्हाट आई मीन टू से, ओके? सो स्टैटिक फॉर्म ऑफ इरोजन एंड डायनामिक फॉर्म ऑफ इरोजन बोथ आर गोइंग हैंड इन हैंड। इज इट फाइन? इट विल गो फॉर हाइड्रोलिसिस। अच्छा, मान लो ये वाटरफॉल कुछ ऐसी जगह है जहां टेम्परेचर कम भी हो जा रहा है, तो फ्रॉस्ट एक्शन भी हो सकता है। सो पॉसिबिलिटी कम है कि वाटरफॉल हो और वहां फ्रॉस्ट एक्शन हो। अक्सर ऐसा नहीं होगा, लेकिन हाँ, ऊंचाइयों पे फ्रॉस्ट एक्शन भी हो सकता है। बट दीज आर द थिंग विच इज वेरी कॉमन इन व्हाट यू कैन से इन अ वाटरफॉल रीजन, एंड नॉट ओनली इट, इन केस ऑफ वेव ऑल्सो द थिंग्स आर कॉमन। when water is the active agent. So you understand that water, a dynamic agent as well as a static agent both, and doing its job, and that's why it is called as the best agent of exogenic force. तो अपनी टीम का ये ऑलराउंडर है. Now let's come to the wind erosion. Wind erosion. So when wind is moving and it is going to carve out certain landform, it is called as aeolian process. Aeolian process, and the landforms which is created are called as aeolian landforms. Just like the river is going to carve out which kind of landform? Riverine land. Riverine land. And when wind is going to cause erosion, it actually causes deflation. There is a process that is called as deflation. So how to understand deflation? What exactly it is? How we should identify or define this deflation? So let me explain this. Suppose that this is a desert area. So what do you expect in desert area? And this is the rock. Fine. This is a rock which has certain height. Fine. This is the height. And in this desert area, we have a lot of sand, small sand. And this aeolian process is actually active in desert area. And there is a wind, moving wind is there. So wind is blowing. Alone wind is not going to create any difference. But what happened? It finds sand. So this is what blowing wind. So due to blowing wind, the sand get blown, and these sand acts as ballistic and continuously colliding onto the lower portion of the rock. Because sand cannot be blown beyond a certain height. That's why the lower rock get eroded more as compared to upper rock. Suppose that it's a hard rock and consistency is same. That means hard rock from top to bottom. But what happened in lower portion, there will be more erosion because of continuous blowing of wind, and wind is blowing the sand and sand is colliding with the rock. And this process is, collective process is called as deflation. And deflation is active in which area? In desert area. In desert area, the agent of erosion is going to be wind. Okay. And the process is called as deflation, or aeolian process. And the landform which is going to be created is called as aeolian landform. In this particular case, the landform which is going to be created is called as rock pedestal. So you'll find in desert area, there is formation of such a rock structure. That is what thinner in the lower side, because more erosion that have taken place. More erosion because of deflation, and upper part less erosion. So you'll find this 40-50 feet height of the rock like this, let's say 50 feet height. So lower, you can say 10 feet is what? Eroded more. Why? Because the sand cannot be blown beyond certain height, isn't it? So lower part get eroded, and there is a formation of this kind of landform, which is called as mushroom rocks. Mushroom rocks. Fine. So mushroom rock are rock pedestal. So how this mushroom rock, rock pedestal, and there are many more other names are like yardangs are there, jujins are there, rock lattices are there, inselbergs are there. We will take up it in detail in landform development chapter. But here I'm just concerned about the process which is taking place. So what is deflation? Sand blown by wind collided with the parent rock, and due to collision, there is a continuous attrition. Here, you can say wind attrition is taking place. Attrition, you remember attrition when two rocks are colliding? So here, wind attrition is taking place, and the lower part get eroded more. And that's why we happen to have such landform. Another landform like, let me explain another landform like yardens. सारे लैंडफॉर्म्स पढ़ेंगे हम लोग बच्चे. जैसे मान लो यार्डेंस कैसे बनते हैं. Suppose that there is a successive arrangement of soft rock as well as hard rock. This is soft rock as well as hard rock. And this is in the area of desert. This is hard rock. Here it is soft, hard, soft, hard rock. And the wind is blowing like this. And you know, wind is taking sand with them, and the process of deflation is going. Deflation. So what happened? And this is what the landmass, which is over here, extensive landmass like this. Fine. For several kilometers, we happen to have this kind of area where the hard and soft rocks are there. You know, this hard rock will be eroded less and soft rock will be eroded more. So what happened? Because of continuous deflation, this hard rock will be eroded less. This is the hard rock. It remain like this, but soft rock will be eroded more, so it will look like this. Hard rock eroded less, but what about softer rock? Eroded more. Hard rock eroded less, but softer rock will be eroded more. So you will find a successive ridge and furrow-like structure. Ridges and furrows. So this is what ridge, which represent hard rock, and this is what furrow that represent soft. Soft rock will be eroded more. And the ridges are extended for several kilometers like this. And likewise, the parallel furrows are also there. Ridges and furrows. Ridges and furrows. Fine. Why these ridges and furrows are being formed? Because of the deflation process. So this is what furrows. For several kilometers. This is furrows for several kilometers. Okay. Furrows for several kilometers. Okay. So ridges and furrows. This ridge is representing hard rock and the furrows representing soft rock. Hard rock, soft rock. Hard rock, soft rock. Hard rock eroded less, but soft rock eroded more. And this kind of a structure is called as yardangs. So where you will likely to find this yardangs? In the desert area. And beautiful such landform will be discussed in detail when we discuss. But what is the process involved? It is deflation. It is deflation. So blowing wind is not alone is going to cause this deflation. So you require this sand. बिना घर के भेदी से ये बात नहीं हो सकती. अगर सैंड इन्वॉल्व नहीं होता तो ये जो टूटन थी वो नहीं हो पाती. बच्चे अपने इन्वॉल्व होते हैं, कभी कभी बहुत बड़ा इरोजन क्रिएट कर सकते हैं, है कि नहीं? So this is what the sand. So the wind along with sand is going to cause deflation. Do remember. And these are the landform which we will discuss in detail in Aeolian process. I hope I made my point clear about deflation. So it is the cumulative effect of sand and blowing wind. Is it fine? And there is a wind attrition which is going to cause erosion, or you can say disintegration of the rock. Obviously, hard rock will be eroded less and soft will be eroded more. And in this case, in case of mushroom rock formation, upper part will be eroded less and lower part will be eroded more. Because wind is blowing over here, so it take the sand. Sand is not blown beyond certain height. Wind उतनी ऊंचाई तक नहीं ले जा सकता. That's why lower part we happen to have part is still intact. Indeed, there will be some erosion, but not as fast as in case of lower rock. So this is what we call deflation. Is it okay to everyone? Deflation is clear? बोले बच्चे. What to remember? The cumulative effect of sand as well as wind deflation and the process, aeolian process. You remember. Is it clear to everyone? And the formation of different landform we will discuss in detail. Yardanks, Geogen, Mesa, Booty, Inselberg, etc. हम लोग आगे पढ़ेंगे. यहाँ तक समझ में आ गया बच्चे? आप लोग लग रहा है चुपके से मैसेज कर रहे हो. मैसेज भी नहीं कर रहे हो. अच्छा मैसेज कर दिया.
यस सर.
ओके. तो बीच बीच में जब मतलब आपके आने चाहिए ना रिस्पांस, ताकि ये लगे कि हाँ आप सीख रहे हैं. ठीक है. So this is how we can see deflation. Next agent is what? Let's talk about wave. So when moving wave is there, how it is going to create the process of erosion. So we all have this idea. The waves are created largely because of blowing wind and the friction this wind is going to cause. So this is the sea level. Fine. And due to the blowing wind, in general, blowing wind, otherwise wave can also be created by tsunami, wind can also be created by cyclone. So due to blowing wind, friction is generated and this friction results formation of wave, and this wave is moving towards the coast, and near the coast it fall like this. So this is a wave. In general, a wave is falling near the coast. और कहाँ पे वेव एक्शन सबसे ज्यादा होता है बच्चे? इन द intertidal zone. Intertidal zone, where the wave action is going to be maximum. What is intertidal zone? It is the area between high tide and low tide. So this is the area where you will find there is continuous wave, which is what? Striking to the coast. This is the coast wave. So we happen to have the wave which is continuously falling. And when the wave is breaking, so it strike to the ground, which is called as swash, and then return back immediately. Which is called as backwash. So there is a swash and backwash. So when swash is there, don't you think that this is the mass of water which is falling from certain height? Answer is yes. There is a free fall of this water. This is a point where the wave is breaking. That is called as breaking point. Breaking point. Where the wave is going to be broken. और जब वेव ब्रेक होती है बच्चे, आप जब देखोगे in high sea, the wave is in continuity. There is a continuous wave. But when wave is going to break, so you'll find that the wave is rising at certain height and then it start falling like this. और जिस समय ये वेव गिर रही होती है, आपने देखा होगा सर्फर्स को इसके बीच से निकलते हुए, देखा है कि नहीं? है ना? So when wave is falling, we call it breaking of the wave. Breaking of the wave. Obviously, this much mass of water is falling under gravity. So under gravity it is falling. So there is a free fall. So don't you think when the water is falling onto the coast, it will create impact? जैसा कि आपने देखा था waterfall के केस में. तो ये वेव बच्चे क्या करेगी, इधर किनारे पे मान लो दिस इज द रॉक विच इज प्रेजेंट at the shore, and here it is the wave like this. In normal case the wave is coming over here, this is the sea level, but when there is a tide, low tide or high tide, so wave is what get extended and it is falling over here also. तो wave क्या करेगा बच्चे, there will be free fall, so obviously there will be certain impact. This is suppose that the rocky structure along the coast, we have this uh, kind of landmass over here, and there is a continuous, what you can say, wave which is colliding with this rock as well as this bottom. So there is a continuous wave which is what falling over there. There is a swash, the falling of the wave, swash, and then backwash. This process is continuously going near the coastline. This is the coast. Okay. Coast. And this is what you can say intertidal zone. Intertidal zone. And high tide will approach, the wave will be little bit higher, so it fall over here. When low tide will be there, wave is falling over here. So obviously, this is what the area where the wave activity is what maximum. So when the wave is falling, there is a swash and backwash, and there is a free fall. And due to this free fall, it was estimated that in general, a normal wave exerts 600 lbs pressure or force per feet square. Wave exert 600 lbs per feet square force. That means on an area of 1 by 1 feet, 1 feet into 1 feet, this falling wave create an impact of 600 lbs. 600 lbs लगभग 280 किलो का फोर्स लगा रही है. यानी अगर एक इंसान यहाँ खड़ा हो और एक इन जनरल नॉर्मल वेव इज फॉलिंग ऑन टू दैट, वो एक इंसान को धक्का मार के दूर ले जाएगी और वापस खींच भी लाएगी. So this is the force which is exerted by a general normal wave. But when there is a winter season, what happened? There is a thermal contraction. Temperature कम होगा बच्चे. Temperature in winter season will be low, and due to low temperature there will be thermal contraction. आप कहोगे सर कितना ही चेंज हो जाएगा? Thermal contraction. And due to thermal contraction, what will happen to the density of water? बोलो, बताओगे तभी आगे लिखूंगा. Water density will increase or decrease? Be participative. In winter season, temperature will be low. There will be thermal contraction. Water density will be
increase.
बताओ भाई, सबको समझ में आ रहा है? There will be increase in water density.
Yes, sir.
एक ही बोल रहा है, लग रहा है इसी ने फीस दिया, बाकी लोगों ने फीस नहीं दिया है. आवाज नहीं आ रही. Water density will
Increase.
हर्षवर्धन, बाकी लोग क्या मतलब पार्टी वार्टी करने आए क्या? श्रेया श्री,
increase, sir.
दीपक ने भी बोला. ना समझ में आ रहा हो तो बोलो कि सर कैसे इंक्रीज. आई विल टेल यू. Increase. So everyone is understanding why increase? That's great. Why it will increase? Because of thermal contraction. Thermal contraction. अच्छा, अब आप कहोगे सर इससे क्या फर्क पड़ जाएगा? So in a general wave that exerts 600 lbs per feet square force, in winter season it was found that the force become 3 times than the general wave. That means, that implies 1800 lbs per feet square. So just because of little change in the temperature, the density has little bit changed, but the force exerted by the wave become 3 times. So if it is doing some kind of erosion, so obviously in winter season, wave erosion will increase or decrease.
Increase, sir.
Increase, sir.
ये बात समझ में आ रही है? बहुत अच्छे. Wave erosion will increase in which season? Winter season. And the force exerted by the falling wave or breaking wave become 3 times. And if it is a general tropical cyclone, it was also estimated कि एक tropical cyclone आ जाए सामान्य सा, उस समय जो water surge होता है, CYCLONE, cyclone. When there is a general tropical cyclone, it will also bring certain water surge. Water surge near the coast. This water surge is nothing but big waves. These big waves are going to collide and it will exert 600,000 lbs force per feet square. 6,000 lbs force per feet square. This is the force exerted by falling wave of a tropical cyclone. It's a water surge in a special case. Tsunami की बात ही छोड़ दो, उसका तो estimation भी नहीं था, है ना? So in general, you will find this normal waves. This is the normal wave as well as winter season's normal wave, and it is continuously falling onto the bedrock of the coast. Suppose that this is the bedrock of the coast. Here it is the coast. Fine. So continuously the water is falling over here and exerting massive force. These are the bedrock. So don't you think there will be hydraulic action? Yes or no? बोलो. Hydraulic action होगा कि नहीं बच्चे?
होगा सर.
भाई hydraulic action में क्या था? It is transferring the kinetic energy, so you must have kinetic energy. And this kinetic energy transferred here. And these are nothing but the bedrock. I denoted bedrock like this with cracks and joints. So there will be kinetic energy that transferred over here and it will create impact and bedrock get loosely held. Don't you think water will enter in the joints? Isn't it? So there will be solution, hydration, blah, blah, blah. Whatever we have discussed, this will also be active over here. And when this rock get loosely held, so there is a swash. Swash is responsible for loosely held rock, and backwash is responsible for taking all these loosely held rock towards the ocean. This is what backwash. बच्चे backwash बड़ा strong होता है. आपने सुना होगा कि लोग कोस्ट के नजदीक पहुंच जाते हैं और लहर उन्हें खींच ले जाती है, and it's a tragic end of life also. So there is a swash that is responsible for transfer of kinetic energy. Bedrock get loosely held because of other activity also. Obviously there will be hydraulic action. So hydraulic action is the prominent process that is going on. Hydraulic action followed by solution, hydration, carbonation, oxidation, hydrolysis and all. And this bedrock get loosely held and there is a swash and backwash. Whatever the bedrock loosely held is taken away by the wave. And this entire process, you try to feel this process. It is not like कि अगर आपसे कहा जाए एक फूल तोड़ना है आपको, एक फूल हो, आप उसे तोड़ना चाहते हो, तो आप हाथ बढ़ाओगे और फूल तोड़ के छुपा लोगे. So what is it? Plucking, ना? So this process is called as plucking. तो अभी जो हम लोगों ने पढ़ा, वो हम लोगों ने क्या पढ़ा बच्चे? Plucking. So waves are performing this plucking. So wave is going to cause plucking. Plucking is a process. जैसे डिफ्लेशन हवाएं करती हैं, वैसे waves क्या करती हैं बच्चे? Plucking करती हैं. And due to plucking, and plucking involves swash and backwash. Plucking involve hydraulic action, plucking involve hydration solution and all that. And why this plucking is there? Because of the force exerted by this wave, and hence this bedrock get loosely held and taken away. Fine. This is what we call plucking. Fine. And the kind of thing which is created at the coast is what, like ये रहा rock आपका जो नीचे से कट गया है, अब थोड़ा सा बचा हुआ है, और ये बना एक प्लेटफॉर्म, और यहाँ है आपका ओशन. दिस इज द sea level over here, but you will find there is a platform created. This is the platform which has been created because of the erosion. Okay, and this platform is called as wave cut, wave cut, wave cut platform. अब जब कभी हाई टाइड आ रही है तो पानी केवल यहीं तक नहीं जा रहा, बल्कि पानी अब यहाँ तक पहुंच जा रहा है. So this is what the area which is what eroded by wave. So this mountain is now called as cliff. So cliff formation and wave cut, platform formation, cave formation, cove formation, arch formation, these all are the example of wave landform, and the process is what? Swash and backwash. Swash and backwash. Is it okay to everyone? Swash and backwash results several types of landform. You will find cave formation, cove formation, geo formation. So we'll take up later, but try to understand the process. So what is the process which is involved over here? The process is plucking, and how it will go on. Let me explain again. So the wave which is dragged by, we are discussing plucking, dragged by continuous wind movement, and when the wave is going to fall, the point is called as breaking point, wave breaking point. अब वेव ब्रेकिंग पॉइंट होता कहाँ है? डिटेल तो बता दूं आपको, लेकिन आपको होगी सर बड़ा साइंटिफिक हो जा रहा है. ओशनोग्राफी का पार्ट है ये, वैसे ज्योग्राफी में नहीं पूछते. ब्रेक कहाँ होती है वेव? जहां पे डेप्थ जो है बच्चे, पानी की गहराई, डेप्थ बिकम हाफ ऑफ द वेवलेंथ. वेवलेंथ जो है, वेव की जो वेवलेंथ है ना, जो लहरें उठ रही हैं, उसका जो तरंग दैर्ध्य है, यानी दो क्रमागत जो एंटीक्लाइन और सिंक्लाइन ही कह लीजिए, क्रेस्ट और ट्रक के बीच में जो डिस्टेंस होती है उसको वेवलेंथ कहते हैं. अब इस वेवलेंथ का अगर हाफ डेप्थ रह जाता है तो वहां पे लहरें टूट जाती हैं, उसे ब्रेकिंग पॉइंट कहते हैं. सो व्हाट इज ब्रेकिंग पॉइंट? इट इज द area where the depth is what? Less than the half of the wavelength. And wave start breaking. और जब वेव टूटना शुरू करती है तो it falls like free fall. It moves under gravity and it create impact, and that impact is called as swash. And after impact, the wave move back, which is called as backwash. In coastal area, especially in intertidal zone, the wave activity is maximum, and in general, it exerts 600 lbs per feet square force, and that erode through various process, and that is what we call plucking, which involve hydraulic action and all. Indeed, this force is what? Triple when there is a winter season. Winter season has higher force because of thermal contraction and increase in density of water. And in a general cyclone, this force is 10 times than the normal per feet square. And when there is a swash and backwash, transfer of kinetic energy takes place, bedrock get loosely held. It's not only hydraulic action, but other activity is also involved that include, fine. And there is a swash, loosely held rock get taken away, which is called as backwash, and collectively we call it plucking. And the coastal area is rewarded with certain landform. Like here, we have seen the example of web cut platform cliff, and in the landform development, we will see other landform formation. So is it understandable to everyone how the plucking takes place because of the wave?
Yes, sir.
The wave is responsible for plucking. Okay, fine, that's great. Let's come to the other process, and that is what? The glacier. Let me talk about glacier. So when glacier is moving, it has a three-dimensional structure. So how many types of glacier we have? We have in general three types of glacier. One glacier, which is called as mountain glacier. Here it is mountain glacier. There is a valley glacier. And there is a continental glacier. There is no much difference between mountain glacier and valley glacier. You understand? When there is a fold mountain, obviously there will be some depressed part which is called as valley. So some glacier which is moving onto the mountain and reaching into the valley. So in the mountain, the glacier is going to cause largely erosion, but in the valley, they go for depositional landform formation. So valley glacier, here it is mountain glacier. How this glacier is going to be formed? So suppose that this is the mountain, and the mountain is what? Very high. So high mountain is there. So as you know, when you move up in atmosphere, there is a decrease in temperature. Decrease in temperature. And this rate of decrease, average decrease is what? 6.5 degrees centigrade per kilometer height. This is also called as normal lapse rate. Normal lapse rate. Okay. This is the decrease when we move in our atmosphere. Here it is the mountain. I'm just talking about mountainous glacier. Mountain. We are talking about mountain glacier. Right? Mountain glacier. Okay. So obviously, suppose that there is a temperature of, let's say, 25 degrees centigrade at the foothill of a mountain. As you move up, there is a decrease of 6.5 degrees centigrade per kilometer. So there will be some area where the temperature goes below 0 degree. So suppose that this is the area where the temperature is 0 degrees centigrade. And above this area, whatever the rainfall takes place, snowfall takes place, it get compacted and it forms, it cover the peak and it get compacted. And this covered peak is what called as glacier. Covered peak is called as glacier. So compacted snow on the mountain is going to create glacier above the snow line. So this is the snow line of the mountain. स्नो लाइन क्या करती है बच्चे? उस एरिया ऑफ माउंटेन को जो बर्फ से ढका है और जो बर्फ से नहीं ढका है उसको डिवाइड करती है. सो above snow line, mountain peak is covered. Mountain peak is snow clad. Snow clad. बच्चे स्नो क्लैडेड हो गया. अब स्नो क्या होगा? धीरे धीरे इट विल कंपैक्ट एंड इट विल फॉर्म द माउंटेन ग्लेशियर. माउंटेन ग्लेशियर. ठीक है बच्चे. अब क्या हुआ कि दिस इज द माउंटेन and this is the mountain snow line. Suppose that this is the snow line. snow line in winter season. अब मुझे बताओ स्नो लाइन इन समर सीजन कहाँ होगी? स्नो लाइन जहां है इस हाइट पे, दिस इज हाइट, लेट्स से h1,
ऊपर होगी।
ऊपर होगी या नीचे, बस ये बता दो।
ऊपर होगी सर।
पक्का?
ऊपर होगी सर।
पक्का ना? दिस इज
यस सर।
स्नो लाइन ऑफ समर, दिस इज स्नो लाइन ऑफ समर सीजन। कोई दिक्कत तो नहीं? क्यों ऊपर होगी ये समझ में आया भाई? विंटर सीजन में देर इज अ 10 डिग्री सेंटीग्रेड टेम्परेचर, तो 0 डिग्री जल्दी पहुंच जाएगा. एंड समर सीजन, दिस इज द विंटर टेम्परेचर. In summer season, we happen to have, let's say, 30 डिग्री सेंटीग्रेड टेम्परेचर. सो ऑब्वियसली 30 डिग्री को जीरो होने में ज्यादा ऊंचाई चढ़नी पड़ेगी, है ना? अब ध्यान दो, जो ये एरिया है बच्चे, दिस एरिया is actually the area from where the glacier detached from the parent glacier. ये वाले तो हो गए parent glacier, parent glacier. लेकिन जो उसके नीचे वाला एरिया है जहां स्नो लाइन ट्रांजिट कर रही है, वहां से ग्लेशियर टूटेंगे और क्या करेंगे बच्चे? दे विल मूव डाउन देयर. दीज आर द ग्लेशियर, डिटैच्ड ग्लेशियर मूविंग डाउन देयर. ठीक है, ये बात समझ में आ गई? यहां ग्लेशियर इरोजन होगा क्या? पेरेंट ग्लेशियर जहां है वहां ग्लेशियर इरोजन नहीं होगा. कहां होगा? जहां से ग्लेशियर टूट के डिटैच हो. सो द एरिया विच इज हाईली एक्टिव फॉर ग्लेशियर इरोजन इज बिलो द समर स्नो लाइन. बिलो द समर स्नो लाइन. इज इट अंडरस्टैंडेबल? So what is mountain glacier? The glacier which is present on the mountain. What is valley glacier? The same glacier, when reaching into the valley region, it becomes the valley glacier. What about continental glacier? Let me explain this continental glacier again. Continental glacier. है ना बच्चे? So we all have this idea that our earth is spherical. Fine. And here we know this is equator. Then we have Tropic of Cancer and Tropic of Capricorn. And what about this? Arctic Circle. And here it is Antarctic Circle. 66.5 degree north and 66.5 degree south. So here we have frigid zone, which is frozen. Here it is also Antarctica, yeah, Antarctic. And this is Arctic. We have the North Pole. And here we have the South Pole. Is it okay? Fine. So continental glacier, when the temperature on the continent is below 0 degree, below 0 degree centigrade, the water on the continent get frozen. So in frigid zone, we happen to have continental glacier near 66.5 degree north and south. We happen to have continental glacier. But what happened when there is a summer solstice? Summer solstice, that is 21st June. So obviously the glacier which is over here, Arctic Circle, is going to be detached and start moving towards the equator under the influence of centrifugal force. Earth is rotating also, na? Earth rotate ho raha hai bachche. So under the influence of centrifugal force, and similarly, the glacier which is detached from the Antarctica also start moving towards the equator. Now, towards the equator under the influence of centrifugal force. So these moving glacier is going to carve out certain landform in which region? In between temperate and Arctic region. तो ये जो एरिया है भाई फ्रिजिड जोन में तो ग्लेशियर मूव नहीं करेंगे और टेम्परेट जोन में भी जब समर सीजन होगा तभी वहां से ग्लेशियर मूव करेंगे विंटर में यहाँ पे भी आइस बन जाती है बट इन समर सीजन इट इज व्हाट moving glacier. So these are the continental glacier which is moving and carving out certain landform on the continent. And similarly, it happens in southern hemisphere on 22nd of December. There is a winter solstice, but summer in southern hemisphere. So continental glacier are present in the rigid zone, but yes, they are active in the respective summer season. Summer season. In summer season, they get detached and they start moving towards the equator under the influence of centrifugal force. Earth is rotating from west to east, and due to this centrifugal bulge, there is always a force which is taking this glacier towards the equator. So centrifugal force. That's why these moving glacier is going to carve out certain landform in the continents also. Okay, in the mountain as well as valley in the continent, we happen to have a glacier. Fine. But let me explain the process which is involved in glacier erosion. So this is a glacier, and this glacier is having three-dimensional structure. It has obviously length, width, as well as height. So glacier is not just like water. This is having a three-dimensional structure. So when moving, such things are moving, they are going to cause friction with the bedrock. This is the bedrock. So bedrock is going to be abrased. ना ये friction लगेगा कि नहीं bedrock पे? Answer है हाँ. This is glacier moving down there, down the hill. So moving glacier down the hill is always in a friction with the bedrock, and it is always in a friction with the side wall also. So this is the side wall. Side wall. So when a glacier is moving, it's going to create a valley, which is what? U-shape. U-shape valley. While the water is moving, it is going to create V-shaped valley because water can take any shape. But when you have a glacier, it has a length, it has a width, as well as it has a height. So three dimension, and that's why there is a continuous friction with side wall. And there is continuous friction with bedrock. And there is a process of erosion that's going on. And collectively we call it cryoturbation. Cryoturbation. Indeed, it involves plucking. It involves attrition. It involves corrosion. And not only this cryoturbation include all these. This cryoturbation also include freeze and thaw, which we talked about frost action. Frost action. Okay. It involves solution, hydration. It involves carbonation. Okay. It involves carbonation. It involves oxidation. So whatever the process you can see here in cryoturbation, everything is going to be. Is it okay? And this cryoturbation is also termed as plucking by glacier. Plucking by glacier. It enters like a bulldozer. Fine. So how this plucking takes place? Let me explain. It's fine. Suppose that this is the mountain, and this mountain is not having a slope, which is what regular slope. Obviously, there will be some terraces, and this is how in nature the mountains are. Suppose that this is the snow-cladded mountain, and from here the glacier is moving. So this glacier moved and it rest for some time over here. Maybe longer time, next season, another glacier is going to push it. Let come over here and again resting over here for some time. Again coming down, resting over here for some time. Again coming down, resting here for some time. And then move forward. This is how the glaciers are moving. It's not like the mountain se seedhe niche chala hai. So these are different terraces where the glacier is moving. I'm just taking one and I'm just magnifying this interface just to show you the process which is going. So इसको मैग्नीफाई करके देखते हैं कि यहाँ क्या है बच्चे. तो यहाँ से एक ग्लेशियर आया और ये एक स्लोप, हॉरिजॉन्टल स्लोप है, और फिर यहाँ से थोड़ी नीचे का स्लोप आप देख पा रहे हैं. यहाँ पे एक ग्लेशियर है एंड देयर इज अ ग्लेशियर which is three-dimensional. I just take this glacier a little bit above from the ground to show something. This is the glacier, na? Glacier. Here, there is a bedrock. ये सारे क्या हैं बच्चे? यहाँ पे bedrocks हैं. उसमें cracks होंगे, joints होंगे. Obviously, bedrock कुछ loosely held होंगे, कुछ smooth rocks होंगी, कुछ resistant भी होंगे, है ना? So this is how the bedrocks are there, arranged over here. This is nothing but bed. These are the bedrocks. Now the glacier is somewhere at lower height where the day temperature goes above 0 degree, above 0 degree, and the night temperature goes below 0 degree centigrade. अच्छा, दिन के समय में क्या होगा बच्चे? यहाँ पे मेल्टिंग ऑफ ग्लेशियर होगी कि नहीं, ये पानी ही दिखाना चाहता था. So in the daytime there will be melting of glacier. दिन का समय है, मेल्टिंग हो गई है. अब यहाँ पानी जब बन जाएगा तो ये जाके इस ज्वाइंट से पूछेगा कि नहीं कि सॉल्युबल हो कि नहीं. बोलो सॉल्युबल. किसी से पूछा आर यू विलिंग टू बी हाइड्रेटेड, है ना? इसने कहा भाई हाइड्रेशन हो जाएगा. किसी से जाके पूछा अच्छा हाइड्रेशन नहीं होगा तो कार्बोनेशन कर लेते हैं. क्यों? क्योंकि यहीं बगल में मिल जाएगा आपको. कार्बन डाइऑक्साइड भी है कि नहीं इसका दोस्त एटमॉस्फेयर में, ऑक्सीजन है कि नहीं. सो दिस विल बी रेडली अवेलेबल. सो ऑब्वियसली देयर विल बी carbonation, hydration and all that. And what about this crack? Suppose that this crack is filled with water. There is a water which is filled over here. तो दिन में तो ये मेल्टिंग स्टेट में है, लिक्विड स्टेट में. रात होगी तो बच्चे देखो हाइड्रोलिक एक्शन होगा, सॉरी फ्रिजन थॉ होगा कि नहीं, बताओ. इट विल एक्सर्ट प्रेशर. धीरे धीरे आप देख रहे हो ये ग्लेशियर यहाँ रुका हुआ है, लेकिन इसके रुकने पे मत जाना. ये यहाँ लगातार कौन कौन से काम कर रहा है आप देख पाए. इट इज कंटिन्यूअसली डूइंग द जॉब, लाइक फ्रीज एंड थॉ, solution, hydration, carbonation, oxidation, hydrolysis. Resting glacier is not going to do this attrition and corrosion, and neither plucking. But all these activity is there where when the glacier is stationary for some time. अब क्या होगा? दूसरा ग्लेशियर आएगा, कहेगा यहाँ क्या कर रहा है, भाग यहाँ से. लेकिन जैसे ही ये ग्लेशियर यहाँ से मूव होके आगे जाएगा बच्चे, जरा सोचो ये बेड रॉक गेट लूजली हेल्ड और नॉट. और जैसे ही ये लूजली हेल्ड बेड रॉक होंगे, क्या होगा बच्चे, ये ग्लेशियर हटेगा तो यहाँ से बेड रॉक्स ऊपर की ओर आ जाएंगे. दे आर लूजली हेल्ड बेड रॉक्स. दे पॉप्ड अप. These are the loosely held bedrocks. They popped up as the glacier moved away. This is the glacier which is moving away. This is the glacier which is moving away. So they get popped up like this. And the preceding glacier is what coming over here. This glacier will move down. And these are the popping up of bedrock, loosely held bedrock. And this loosely held bedrock will be bulldozed, or it will be removed by the glacier number 2. Glacier number 1 is doing what? All those activity. But glacier number 2 is going to bulldoze it. And obviously this glacier number 1 is for number 2 for the earlier glacier. तो यहाँ पे क्या होगा बच्चे, ये जो बेडरॉक है ना, यहाँ से धीरे धीरे इस बेडरॉक को यहाँ से रिमूव किया जाएगा और यहाँ एक डिप्रेशन बनता चला जाएगा slowly and gradually, and this depression is what called as glacial lake. Glacial or glaciated lake, या इसी को एक नाम दिया जाता है बच्चे, पैटरनॉस्टर. पैटरनॉस्टर लेक. ग्लेशिएटेड लेक फॉर्मेशन कैसे हो रहा है, और कलेक्टिव प्रोसेस ऑफ ऑल दीज मीन्स देयर इज plucking, attrition, erosion, freeze thaw is called as cryoturbation. Cryoturbation involve all these processes, and slowly and gradually this part become deeper and deeper, and in summer season these deeper part contains water like this, salt water over here. So this is what salt water. Salt or brackish water. It's not a fresh water, brackish water in these lakes. And these lakes are called as glaciated lake. For example, if you have seen Three Idiot movie, there is a Pegang. So we have Nainital Lake. We have Tallital, Mallital, and number of lakes are there. Tallital, Mallital. सुरिनसर मानसर, ये सब नाम आप सुनेंगे. सुरिनसर मानसर. It is in Jammu Kashmir, one of the Ramsar Convention site. It's a glaciated lake which is developed on the mountain slope. Fine. So how it was developed? Because of the process of cryoturbation that involved plucking by the glacier, and basically this plucking is containing all these attrition, erosion, along with fridge and thaw, solution, hydration, and all. Isn't it? So this is how the glacier is going to create landfall. So it will create glaciated lake, it will create U-shaped valley. तो आप देखोगे कि ये U-shaped valley mountain से जैसे जैसे आप नीचे आ रहे हो, it is protruded just like a finger from the mountain. So it looks like finger. These are the U-shaped valley. So many U-shaped valley are arising from the mountain and coming down the hill like this. So it looks like finger. That's why these are U-shaped valley. That's why we refer this U-shaped valley as a finger area also. You might have heard the term finger area. Fine. So finger area, and paternoster lakes are studded in these U-shaped valley like this, here and there. On each and every, what you can say, terrace of the slope, we happen to have this paternoster lake. It looks like as if the mountain is wearing a beaded necklace. मोती की माला पहन रखा हो mountain ने, इस तरह की ये दिखती है. That's why paternoster lake These are Paternoster Lake. And here we have U-shape, glaciated valley. So whenever we have glaciated valley of U-shape, whenever we have a U-shaped valley in the hilly area, certainly it is because of glacier. And the characteristic feature of these U-shaped valleys is what presence of this glaciated lake, Paternoster Lake. It looks like as if mountain is wearing a beaded necklace. That's why sometimes it is also referred as beaded necklace topography. Beaded necklace topography. So again, in the landform development, we will meet it. फिर देखेंगे हम लोग उसके original formations. You remember these example, but moreover, what to understand, what is the cryoturbation or plucking by glacier? What is the plucking by glacier? So it involves all these process, and how this process is there, I have discussed, because we require a temperature change. The day temperature must be more than 0 degree and night temperature must be less than 0 degree centigrade. There is melting that takes place. Melting of glacier takes place. Entire melting is not there, but some amount of water is what in liquid state, or liquid water is mischievous. Liquid water, बदमाश है जी. Liquid water, वेपर फेज और ग्लेशियर फेज, किसी भी फेज में ये बदमाशी करना नहीं छोड़ता. दैट्स वाई वाटर इज द बेस्ट इरोजनल एजेंट, है ना. ये हाइड्रोलिक एक्शन भी दिखाता है, कैविटेशन भी करता है, फ्रिज एंड थॉ भी करेगा, और लोग नहीं माने तो सोल्यूशन हाइड्रेशन तो करता ही है. सो आई होप आई मेड माय पॉइंट क्लियर टू यू. यू अंडरस्टूड दिस. इज इट ओके टू एवरीवन?
Yes, sir.
Shall I stop here? आज यही रुकते हैं फिर. इसके आगे की कहानी, मतलब मैंने इरोजन बता दिया आपको. और yes, मानसरोवर एंड राक्षस लेक इज ऑल्सो अ ग्लेशिएटेड लेक. मानसरोवर लेक को हम लोग टार्न ज्यादा कहते हैं बच्चे. इट्स अ सर्क लेक, अर्कोरी लेक. ठीक है, सर्क अर्कोरी लेक, है ना. थोड़ा सा डिफरेंस होता है सर्क या कोरी लेक. मैं बता दे रहा हूँ क्या डिफरेंस होता है. जैसे जब जहां पे ग्लेशियर चलना शुरू करते हैं, सो दिस इज द पीक विच इज नॉट इरोडेड बाय द ग्लेशियर. लेकिन यहाँ से जब ग्लेशियर नीचे चलते हैं तो ग्लेशियर यहाँ पे बना देते हैं पिरामिडल पीक. तो पीक कुछ इस तरह से बन जाता है. दिस इज व्हाट अनइरोडेड पीक, बट बिलो इट you will find a C-shaped structure like this. So this peak is called as Har or pyramidal peak. And this is called as Sark. Sark, or it is also called as Kori. अब यहाँ भी ग्लेशियर कुछ दिन तक रुका रहता है जस्ट बिलो द पिरामिडल पीक, है ना. तो यहाँ जब ग्लेशियर रुका रहता है तो ये भी क्या बनाता है बच्चे, डिप्रेशन बना के यहाँ लेक बनाता है. तो जो लेक सबसे पहली पैटर्नोस्टर लेक है पिरामिडल पीक के जस्ट नीचे, उसको टार्न या कोरी कहते हैं. दिस इज समथिंग लाइक दिस. ये यहाँ पे पिरामिडल पीक है बच्चे. इट लुक लाइक दिस. सो दिस लेक इज कॉल्ड एज टार्न या कोरी. खास बात इस लेक की ये होती है कि इन विंटर सीजन इट इज फ्रोजन. It is frozen. Generally, it is frozen. And in summer season, it is what? Unfrozen. So water unfrozen state. ये तो हुई बात आपके सबसे पहली लेक जो पिरामिडल पीक के नीचे है. अब माउंटेन कुछ इस तरह से है. This is the pyramidal peak. Here you have tar, then another lake over here, and another lake over here, then another lake. So all these lakes are going to be called as Paternoster Lake. जैसे जैसे आप नीचे चलते चले आएंगे, अक्सर ये लेक्स क्या होती हैं बच्चे, पानी इनमें समर और विंटर सीजन में भी नहीं जमता। लेकिन ये जो पहली लेक थी ना, इसको इसका पानी विंटर सीजन में जम जाता है, पिरामिडल पीक के जस्ट नीचे। तो जो राक्षस ताल है या फिर मानसरोवर लेक है, वो इस कैटेगरी की लेक है। बाकी नैनीताल, मल्ली ताल, तल्ली ताल, नौकुचिया ताल, and your what you can say Surinsar, Mansar, and number of lakes are there. उधर आप कनाडा में चले जाओ तो अथाबास्का लेक, ग्रेट बियर लेक, रेंडियर लेक, विनीपेग लेक, वो कॉन्टिनेंटल ग्लेशियर से बनी हुई पैटर्नोस्टर लेक से। सो दीज आर द लेक। और वो भी ऐसा नहीं है कि वो फ्रोजन नहीं होती, विंटर सीजन में वो फ्रोजन होती है, बट जनरली दीज लेक्स आर व्हाट, डाउन द हिल। Okay, down the hill lakes are what normal glaciated lake, and this first lake is what Paternoster Lake, or you can say Tarn Lake. Okay, so you remember this? Is it fine? तो रखा जाए भाई।
सर
हाँ,
ब्रेकिश वाटर समझ में नहीं आया।
ब्रैकिश वाटर नहीं समझ में आया, अच्छा सवाल है। ब्रैकिश वाटर इसलिए है बच्चे कि आप एक्सपेक्ट क्या कर रहे हो कि यहाँ पे फ्रेश वाटर होना चाहिए। अब फ्रेश वाटर आपको कहाँ मिलेगा, पहले ये भी बता। जहां ग्लेशियर मूव ना करे, मेल्ट हो रहे, जैसे ये ग्लेशियर है, ग्लेशियर का नाम है गंगोत्री ग्लेशियर, गंगोत्री हो सकता है, ये सतोपंथ हो सकता है, सतोपंथ ग्लेशियर, ये अब बहुत सारे ग्लेशियर हैं। मतलब जब ग्लेशियर मेल्ट होकर के क्या बना रहा हो, वाटर, और यहाँ से कोई नदी निकल रही हो, रिवर, तो ये जो पानी होगा, ये पानी जो होगा वो फ्रेश वाटर होगा, फ्रेश वाटर। लेकिन जब ऐसा हो कि ग्लेशियर मूव कर, वो ग्लेशियर मूव करके कहीं आके रुक करके एक गहरी झील बना रहा है और उसके आगे चला जा रहा है, तो हर बार ये ग्लेशियर यहाँ आएगा तो अपने साथ ये सेडिमेंट डिपॉजिट लाएगा कि नहीं, जो यहाँ पे लाया जाएगा, फिर यहाँ से उठा के इसको आगे ले जाया जाएगा। तो वेन एवर द सेडिमेंट डिपॉजिट इज हियर, सो ऑब्वियसली इट विल एक्यूमुलेट सॉल्ट। तो कई मिलियन साल से ये ग्लेशियर चलते आए हैं और यहाँ पे आके इसमें एक्यूमुलेट करते हैं, जैसे नदियां समंदर में सॉल्ट एक्यूमुलेट करती हैं, ठीक वैसे ही। इसलिए ग्लेशिएटेड लेक्स जो होती हैं वो जनरली ब्रैकिश वाटर, उनका पानी आप पी नहीं सकते, सॉल्टी वाटर होते हैं बच्चे, ब्रैकिश। So we happen to have brackish water in which lake? In glaciated lake. लेकिन आप कहोगे सर नदियां जो आती हैं तो वहां ध्यान दो, तो ग्लेशियर मूव नहीं कर रहा। जब आप गोमुख पहुंचते हो ना, गोमुख, तो वहां देखते हो कि ग्लेशियर पिघल रहा है, पिघल के वो फ्रेश वाटर के रूप में आ रहा है, तो वहां भागीरथी, अलकनंदा और आगे आके गंगा ये बनती है। आप समझ पाए? So
यस।
there is a clear-cut difference when the glacier is melting and when the glacier is moving. And moving glacier is going to create this Paternoster Lake. Paternoster Lake. While melting glacier is creating a spring. जैसे वेरीनाग स्प्रिंग, नाम सुना है वेरीनाग? वेरीनाग स्प्रिंग कहाँ मिलेगी बच्चे? जम्मू कश्मीर में, यहीं से झेलम निकलती है, झेलम, गोमुख, जहां से भागीरथी निकलती है। इज इट फाइन? केदारनाथ, अलकनंदा निकलती है। सो दीज आर द ग्लेशियर, isn't it? So moving glacier is creating this paternoster lake, melting glacier creates river, और ये river containing fresh water, while the moving glacier is making the paternoster lake which is having brackish water. तो पेगांगसो का अगर आप पानी पीते हो तो आपको क्या मिलेगा? खारा पानी पी नहीं पाओगे। इज इट ओके टू एवरीवन?
यस सर।
ओके, ठीक है
Yes.
बच्चे, फिर रखते हैं, आज कल मुलाकात होगी। थैंक यू वेरी मच।